dependency of resistivity. See, we know the formula for for RT. RT is resistance. What is the formula? Formula we studied, that was RT naught 1 plus alpha T minus T naught. And the same formula, for resistance was this, and for resistivity it was this formula. So from this formula, what we can conclude, see, for metal, we are discussing about the metal. In short, if you will study for metal, see, what is this? This is nothing but your temperature. This is temperature in Kelvin. And this is your resistivity into 10 raised to power minus 8 ohm meter. See, if you increase the temperature, what about resistivity? Yes, your resistivity will get increased. Okay, so for metal, it is directly proportional. For metal, it is directly proportional. Okay, then if we study about the alloy, check this one. If we study about this alloy, in this alloy, what will happen? This is your temperature, this is your resistivity. See, some material like our nichrome, constantan is a material from which resistance is made. Nichrome, manganese, constantan, they exhibit very weak dependency of resistivity with temperature. Hence, it is used in wire bound resistance. These three things are used in wire bound resistance. So what will be the relation of resistivity with respect to temperature? It has been shown in this diagram. Now, if we speak about the semiconductor, for semiconductor devices, check, this is our resistivity, this is our temperature. This is showing the graph like this. What this graph means? This graph means, yes, that your resistivity is inversely proportional to temperature. If you increase the temperature, resistance will get down. If you decrease the temperature, this resistivity will get increased. So what we have concluded from this three things, we have concluded that for metal, for alloy, and for semiconductor, the behavior of resistivity with respect to temperature will be different. Okay, so let's see some questions related to it. First of all, yes, the first question: resistivity of semiconductor decreases with dash of a temperature. First question: resistivity of semiconductor decreases with dash of a temperature. Anyone? First question. Options are A, decrease, B, increase, C, decrease or increase, or D, none of these. Let me check the comment section. Anyone? Resistivity of semiconductor decreases with dash of a temperature. Semiconductor. What is semiconductor? Yes, we know about semiconductor that if temperature increases, resistance will get decreased. This is resistance, this is temperature. Okay, that means what? If resistivity is decreasing, what about temperature? Temperature will get increased. So what will be your answer? Answer will be answer B, increase of a temperature. Okay, let's solve the next question. Which of the following is not the property of fuse? Which of the following is not a property of fuse? Options are: conductivity of fuse must be high, B, melting point of fuse is high, C, it is protective equipment, D, it can be made up of alloy of lead and tin. It is not a property of fuse. Which of these is not a property of fuse? Anyone? B. Akhil, B. Yes, B is the right answer. Very good. Why? Why B? See, what is the function of fuse? If there is a overcurrent, then it will melt easily. After it melts, the circuit will get break, and hence there no flow of charges or current will be there. So this is not a property of fuse. The melting point of fuse is very, very low. It's not high, it is low. So your right answer will be what? Your right answer will be option B. Very good, Akhil. Third one. Yes. VI characteristic of metallic wire at two different temperature T1 and T2 are shown in the figure. Which of the two temperature is lower and why? Which of the two temperature is lower and why? For a metallic wire it is for a metallic wire. Okay, for a metallic wire. T1 and T2 are given. Which of the two temperature is lower and why? Anyone? Which temperature is lower? T1 or T2? T2. T2? Yes, Akhil, very good, very good. But I hope you are not doing Google copy pasting. Okay, so the VI characteristic of metallic wire is shown T1 and T2. Which of the two temperature is low and why? Which of the two temperature is low and why? Now just see, we have IV characteristic. IV characteristic. If you conclude, see, IV of this will be greater. IV will of this will be greater than this one. I mean, IV of red will be greater than blue one. Huh? See, I upon V is greater. I upon V is greater. See, V upon I is resistance. That means I upon V will be what? It will be conductance. So that means conductance of 1 is greater than conductance of 2. Once more. See, resistance is what? Resistance is V upon I. But here it is not the ratio of V upon I. It is the ratio of I upon V. Okay, so what is V? What is I upon V? If you check I upon V, I upon V will be conductance. That means what? Your conductance of 1 will be greater than conductance of 2. Achha, what is conductance? Conductance is the reciprocal of resistance. That means 1 upon R1 will be greater than 1 upon R2. If this is the thing, that means R2 will be greater than R1. See, if R1 is great, R1 is smaller, R2 is greater. We know that in the metallic case, in the case of metal, we know that temperature is directly proportional to resistance. Now we have studied. So if R2 is greater, that means what? That means T2 will be greater than what? T1. Okay. And the right answer goes to Mr. Akhil. Okay, so this is why your T2 will be greater than T1. Okay, once more, see what we have in this question. In this question, we have a metallic wire with temperature T1 and T2. Okay, okay, fine. See, this is greater than this one. No? I mean, this is greater than this one. T1 is greater than T2 here in this case. For a time being, just understand. See, here I upon V is greater for 1 than I upon V of 2. V upon I is resistance. What is I upon V? I upon V is your conductance. That means what? Your conductance 1 will be greater than conductance 2. That means what is conductance? It is a reciprocal of resistance. That means 1 upon R1 will be greater than what? It will be greater than 1 upon R2. That means what? That means R2 will be greater than R1. Therefore, what is R2? What is R2 is greater than R1. We know that in the case of metal, your temperature is directly proportional to resistance. That means your T2 will be greater than T1. Hence, temperature T2 will be greater. Okay, next.